The National Electrical Code, or NEC, does not explicitly specify whether fuseholders for supplemental fusing and high-intensity discharge, or HID, roadway luminaries must be two-pole or single-pole type. However, industry best practice and safety considerations suggest that two-pole type fuseholders should be used. Here are the reasons why. Firstly, backfeed prevention. Two-pole fuseholders interrupt both the line and neutral conductors, ensuring that backfeed cannot occur if the branch circuit disconnect is not turned off. Secondly, safety during maintenance. Using two-pole fuseholders ensures that both conductors are simultaneously disconnected during maintenance or testing, reducing the risk of electrical shock. Thirdly, single-point disconnection. Two-pole fuseholders provide a single point of disconnection for both conductors, simplifying maintenance and troubleshooting. While the NEC does not prohibit the use of two separate single-pole fuseholders, there are potential drawbacks to this approach. One potential drawback is an increased risk of backfeed. If one of the single-pole fuseholders fails or is bypassed, backfeed can occur. Another potential drawback is incomplete disconnection. Using two separate fuseholders means that both conductors are not simultaneously disconnected, which increases the risk of electrical shock during maintenance. Based on industry best practice and safety considerations, it is recommended to use two-pole type fuseholders for supplemental fusing and high-intensity discharge, or HID, roadway luminaries to prevent backfeed, ensure safety during maintenance, and provide a single point of disconnection. Supplemental fusing in high-intensity discharge, or HID, roadway luminaires serves to protect the individual luminaire and the branch circuit from overcurrent conditions. These fuses are typically located within the base of the luminaire or in a nearby enclosure. The purpose of these fuses is to isolate a faulty luminaire from the rest of the circuit, preventing a short circuit or other overcurrent event from affecting other luminaires or equipment connected to the same branch circuit. Fuseholders are the devices that physically hold the fuses in place and provide a secure electrical connection. They are designed to accommodate specific fuse sizes and types and are rated for specific voltage and current levels. Fuseholders are essential components of the overcurrent protection system and must be properly selected and installed to ensure reliable operation and safety. The NEC provides guidelines for the selection and installation of fuseholders to ensure that they are suitable for the intended application and can withstand the expected electrical stresses. Backfeed refers to the situation where electrical current flows in the opposite direction from its intended path. In the context of roadway lighting, backfeed can occur if a luminaire is still energized even when the branch circuit disconnect is turned off. This can happen if there is an alternative path for current to flow, such as through a faulty ballast or a wiring error. Backfeed can create a significant safety hazard for maintenance personnel, as they may assume that the circuit is de-energized when it is not. It can also damage equipment and create the potential for electrical shock. Two-pole fuseholders are designed to interrupt both the line and neutral conductors of a circuit, providing a complete disconnection of the luminaire from the power source. This eliminates the possibility of backfeed, as there is no longer any path for current to flow to the luminaire when the disconnect is turned off. Single-pole fuseholders, on the other hand, only interrupt one conductor, typically the line conductor. If the neutral conductor remains connected, there is still a potential for backfeed to occur through the neutral conductor. This is why two-pole fuseholders are recommended for applications where backfeed prevention is critical, such as roadway lighting. Incomplete disconnection refers to the situation where one or more conductors of a circuit are not fully disconnected when the disconnect switch or circuit breaker is turned off. This can occur if the disconnect switch is faulty, if there is a wiring error, or if single-pole fuseholders are used and one of the fuses fails to open. Incomplete disconnection can create a significant safety hazard for maintenance personnel, as they may assume that the circuit is de-energized when it is not. It can also lead to equipment damage and electrical shock. Two-pole fuseholders provide a more complete disconnection of the circuit, as they interrupt both the line and neutral conductors simultaneously. This reduces the risk of incomplete disconnection and enhances safety during maintenance and troubleshooting. A single point of disconnection refers to a location where all conductors of a circuit can be disconnected simultaneously with a single action. This simplifies maintenance and troubleshooting, as it allows personnel to quickly and easily de-energize the entire circuit without having to locate and operate multiple disconnect switches or circuit breakers. Two-pole fuse holders provide a single point of disconnection for both the line and neutral conductors of a luminaire. This makes it easier to de-energize the luminaire for maintenance or troubleshooting purposes. Single-pole fuse holders, on the other hand, require separate disconnection of the line and neutral conductors, which can be more time-consuming and increase the risk of errors. When selecting fuse holders for roadway lighting applications, it is important to consider the voltage and current ratings of the fuses, as well as the environmental conditions in which the fuse holders will be installed. Fuse holders must be rated for the maximum voltage and current that the circuit is expected to carry. They must also be suitable for the temperature, humidity, and other environmental factors that they will be exposed to. In wet or damp locations, it is important to use watertight or weatherproof fuse holders to prevent moisture from entering the fuse holder and causing corrosion or electrical faults. It is also important to select fuse holders that are compatible with the type of fuses being used. There are many different types of fuses available, each with its own unique characteristics and performance specifications. Fuse holders must be designed to accommodate the specific type of fuse being used to ensure proper electrical contact and reliable operation. The NEC provides detailed requirements for the installation of fuse holders. These requirements cover topics such as the location of fuse holders, the spacing between fuse holders, and the methods used to connect conductors to fuse holders. It is important to follow these requirements carefully to ensure that the fuse holders are installed safely and correctly. Proper installation of fuse holders is essential for ensuring the reliable operation of the overcurrent protection system and for preventing electrical hazards. The specific National Electrical Code, or NEC, articles that are most relevant to fuse holder selection and installation include firstly Article 240, which covers overcurrent protection in general, including fuses and fuse holders. Secondly, Article 410, which covers luminaires, lamp holders, and lamps, including requirements for supplemental fusing in luminaires. Thirdly, Article 406, which covers receptacles, cord connectors, and attachment plugs, including requirements for tamper-resistant and weather-resistant receptacles. And fourthly, Article 314, which covers outlet boxes, device boxes, and conduit bodies, including requirements for the installation of boxes and conduit bodies in wet locations. These articles provide detailed requirements for the selection, installation, and use of fuse holders in a variety of applications. It is important to consult these articles when designing and installing electrical systems to ensure compliance with the NEC and to ensure the safety of personnel and equipment. The NEC does not explicitly mandate the use of two-pole fuse holders for high-intensity discharge, or HID, roadway lighting, but it does emphasize the importance of safety and proper overcurrent protection. The NEC provides general requirements for overcurrent protection in Article 240, which includes fuses and fuse holders. These requirements are designed to protect electrical circuits and equipment from overcurrent conditions, such as short circuits and overloads. The NEC also provides specific requirements for luminaires, lamp holders, and lamps in Article 410. This article includes requirements for supplemental fusing in luminaires, which is intended to protect individual luminaires from overcurrent conditions. While the NEC does not explicitly require two-pole fuse holders for high-intensity discharge, or HID, roadway lighting, it does state that all electrical equipment must be installed in a neat and workmanlike manner and that all electrical connections must be made in a safe and reliable manner. This implies that the selection and installation of fuse holders should be based on sound engineering practices and safety considerations. In addition to the NEC, there are also industry standards and best practices that recommend the use of two-pole fuse holders for high-intensity discharge, or HID, roadway lighting. These standards and best practices are based on the experience of electrical engineers, contractors, and maintenance personnel who have worked with roadway lighting systems for many years. They reflect the consensus view that two-pole fuse holders provide a higher level of safety and reliability than single-pole fuse holders. Ultimately, the decision of whether to use two-pole or single-pole fuse holders for high-intensity discharge or HID roadway lighting is a matter of engineering judgment. However, it is important to consider all relevant factors, including the requirements of the NEC, industry standards and best practices, and the specific characteristics of the lighting system. In most cases, the use of two-pole fuse holders is the best option for ensuring safety and reliability. When choosing between two separate single-pole fuse holders versus a single two-pole fuse holder for high-intensity discharge, or HID, roadway lighting applications, several factors should be considered. Firstly, safety. Two-pole fuse holders enhance safety during maintenance by ensuring both conductors are disconnected simultaneously. This reduces the risk of electrical shock. Single-pole fuse holders, if not properly managed, could leave one conductor energized, posing a risk. Secondly, backfeed prevention. Two-pole fuse holders interrupt both line and neutral conductors, preventing backfeed when the branch circuit disconnect is off. Single-pole fuse holders might not completely prevent backfeed if only one conductor is interrupted. Thirdly, ease of maintenance. Two-pole fuse holders offer a single point of disconnection for both conductors, simplifying maintenance and troubleshooting. Separate single-pole fuse holders require disconnecting each conductor individually, which can be less efficient. Fourthly, code compliance. While the NEC doesn't explicitly mandate two-pole fuse holders, compliance with standards that prioritize safety and complete disconnection is essential. Two-pole fuse holders align better with these safety-focused standards. Fifthly, reliability. A single two-pole fuse holder unit may offer more robust and reliable disconnection compared to two separate single-pole units, reducing potential points of failure. In summary, although the NEC does not explicitly require two-pole fuse holders, the industry best practice leans strongly towards their use in high-intensity discharge, or HID, roadway lighting for enhanced safety, effective backfeed prevention, and simplified maintenance.